Fast forward a few decades, and the V model has emerged as a common development cycle used in embedded systems. The V model adds two critical things that are missing from the waterfall. The first one is that it adds the idea of tying tests to different layers of design to be more effective finding defects earlier before product test. And the other is better support for decomposition so that if there are multiple teams working together on a product, it's easier for them to collaborate within the context of the software development cycle. The V is called the V model because it looks like a V, as we'll see. The first step in the V is to specify a product, and the output of that step is product requirements. So now you know what product you're trying to build. The next step is to specify software, and that puts out software requirements. Now you know the software's role in the product. The next step is to create a software architecture, and that results in a high-level design. So you've done the requirements, you know what you're building, and the architecture is the general way the components and functions will be organized to build it. After that comes designing the different software modules, so those are the pieces within the architecture, and each module ends up with a detailed design. Now it's time to implement, which means writing the code, and to create source code. Now to this point, this looks an awful lot like the waterfall, and in fact, it's very much like a waterfall. The one nuance in there is that there's a presumption that the designing of modules might be done by different teams in parallel. And so as you go down the V, things break apart into pieces, and as we climb back up the V on the other side, they come together to integrate a system. Once you have the source code, in the waterfall, it just says do test, and typically that ended up being system test. But the V is more nuanced about it. The V says, all right, after you have source code, we're going to do a thing called unit test. And unit test is going to take what was in the design of the modules and just make sure each module works without worrying about what other modules are doing. So each module design team can do its own unit tests in parallel, and you can test without waiting for the whole system to be done. The unit test results find some bugs, so it's another layer in the Swiss cheese model. And then you take the units, you assemble them into subsystems, and you look at how all the units play together. Basically, you assemble the units into the high-level design and make sure that the system conforms to the high-level design, that it works the way you thought it did, assuming the units are already taken care of because you've already done unit test. Finally, you integrate all the software into the whole software system. You do software test. And only then do you do acceptance test on the product. So the last thing you do is a product test, and that should just pass except for potential some weird hardware-software integration issues, because you've already thoroughly tested the software and you've done a methodical design. Now the piece that's missing are some arrows that go back and forth that explain how these things relate to each other. So for example, on the upper left, there's a specify the product, and that goes to the acceptance test. In other words, when you're done with a product spec, you create a test plan, and that test plan ties to acceptance test, and the acceptance test is supposed to test what's in the product spec. Going down, the software test tests against the software requirements, the integration test tests against the high-level design, and unit test tests against the detailed design. Now that's a lot of different testing, but each one is focusing on something different. So for example, integration test assumes the unit tests passed, therefore it assumes the detailed designs are correct, and it's really just interested in do the things play well together, not internal logic flaws. This way of looking at the development cycle emphasizes traceability and emphasizes saying, okay, well, you said you were going to do something, did you really do it? The said you're going to do something is on the left side of the V, did you really do it is on the right side. Peer reviews of all work products happen, so everything that is a work product and output, for example, software requirements or detailed design or source code, all those things are subject to peer review as an extra quality check. And so this way you have two ways of finding defects. You take a look and make sure the thing coming out of the box makes sense. And then later on in test, you go back and say, well, yeah, we created that thing. Does what we created actually match what's in the box? And by the time you're done at acceptance test, if you've done a good job, you're finding very few bugs in acceptance test.